Hello everyone, and welcome to your video on special right triangles. These are right triangles that have fixed and interesting relationships between the angles and the sides. And your life will be a lot easier if you can quickly recognize each of these triangles. So the first thing that you need to know is that the triangles have different names. This triangle here is called a 45-45-90 triangle. And the reason it's called that is because that is the measurements of these angles. This is a 45-degree angle, a 45-degree angle, and a 90-degree angle. So it's called the 45-45-90 triangle. It does have another name. It is also called the 1-to-1 to radical 2 triangle. And the reason is that these two sides are the same length, and this one is a 1 to the radical 2, or sometimes just called radical 2. So the name of the two names of this triangle kind of gives you a reminder of what the angle measurements are and what the side lengths are. This second right triangle is called a 30-60-90 triangle. And the reason for that is that one of the angle measurements is 30, one of the angle measurements is 60, and then the last one is 90. This is also called the it should be called this, the 1 to 3, root 3 to radical 2, because it goes like this. But we don't call it that because it's cooler if we call it the 1 to 2 to radical 3, because then you have your 1, 2, 3 in order. But notice that the 30 is across from the 1. The 60 is across from the root 3, and the 2 is across from the 90. So that's a little goofy here. Here, let me get a different color for you. This is a little goofy, but nevertheless, that's what we call it. We call it the 1 to 2 to radical 3. And then this triangle over here doesn't have any angle measurements, and the reason because the angle measurements are weird. But it does have a name, and it's called the 3-4-5 triangle. And that's because one length is 3, one length is 4, and the hypotenuse is 5. Okay, so let's look at each of these types of triangles for just a few seconds and get some examples of how you can use them. So first we're going to start with the 45-45-90 triangle. And if I had such a triangle, and if it looked like this, which is just an approximation of what a real one looks like, let's say that I see this triangle and I know that this side is 4 and this side is 4. I know that I'm dealing with a 1-to-1 to radical 2 situation because I can see that these two sides equal each other. They're in the ratio of 1-to-1. They could be 3.57 and 3.57, or 1,000,006 and 1,000,006. It doesn't matter as long as they match. And then it's easy for us to figure out this other side, because we just write whatever this number is, and then we plop a radical 2 behind it. That's it. So this is length 4, this is length 4, and this is length 4 root 2. Also, by the way, just by giving these two sides equal to 4 information, we also know that our angle measurements are 45 degrees each. Okay, let's do another example. Let's say that we have this triangle, and we know that this angle is 45 degrees, and we know that this angle is 45 degrees. We also know that this is a 6. Okay, so we can figure out a lot here. We know it's a 45-45-90 triangle. We know that this leg is a 6, so we know that this leg has to be a 6, because 45, 45, 90 also means 1 to 1 to radical 2. And we know that this side over here is going to be a 6 root 2, because you just take whatever this is and you plunk a root 2 on the end of it. Okay, last one for our 45, 45, 90 triangles. This time, we know that this is a 45, and we know that this is an 8. Okay, that's what we know. Well, we automatically know that this is a 45 degree over here. Why? Well, because my triangle has to add up to 180. I've already used 90 and 45. The only thing this could be is a 45. I have this 8 right here. If I want to get one of the sides, remember I took the side and plopped on a radical 2. So I have 6 times radical 2 up here. So here I need to get rid of the radical 2. So this would be 8 divided by radical 2. And this side would be 8 divided by radical 2. Now, you could rationalize that denominator if you wanted to, but that's how you would do it. All right, so 45, 45, 90, very straightforward and not too confusing. Now we're going to skip over here to the 3, 4, 5 triangle. Why? Well, because it's easier than the middle one. and I figure start easy, then get hard. Okay, so a 3, 4, 5 triangle. What makes a 3, 4, 5 triangle tricky is that they usually do not have the leg measurements in terms of 3, 4, and 5. So for instance, this is also a 3, 4, 5 triangle because this is 3 times 2, 4 times 2, 5 times 2. So I've just taken my 3, 4, 5 ratio and I've multiplied everything by 2. Likewise, if this was the information I was given, I know that this over here has to be 500 because I can see that it's a 3, 4, 5 triangle and these this side was multiplied by 100 and this side was multiplied by 100, and so this side must also be multiplied by 100. Okay, I'm going to give you one more. And if I tell you that this is like this, you should be able to tell me that this is a 3, 4, 5 triangle. These two can both be divisible by 4. We get a 3 here, right? 12 divided by 4 is 3. We get a 5 here. 20 divided by 4 is 5. And so this is going to be our 4 side. Multiply it by 4. Get 16. Again, a 3, 4, 5 triangle. Because I could take this. I can divide each one by the same number, which is 4. And I get 3, 4, 5. So it takes a little bit of practice to get used to seeing the 3, 4, 5 pattern. It's easier in certain numbers, like when we multiply by 100 or when we stick with small numbers like here. But if you keep your eyes open for them, you will find them a lot, especially on standardized tests. And it makes your life go a lot faster if you don't have to write out the Pythagorean theorem. You just know, hey, that's got to be a 10 because that's a 3, 4, 5 triangle. Okay, so now let's look at the center section, which I hope I didn't scare you when I said it was the hardest one. It is the hardest one, but the reason it's the hardest one is because these numbers don't line up quite the way they should. But let's do a few examples, and then I bet you'll start to feel better about the whole thing. Okay, so let's draw a 3, 4, 5 triangle. It looks more like a 45, 45, 90 triangle, but we are going to pretend. And we know that this side right here is 30 degrees, and we know that this side here is 60 degrees. So really it would be more like this. There, okay. Just pretend. Okay, so that's what we know. We know that it's 3, 4, 5, 30, 60, 90 triangle, and we know that this is side length 5, okay? We know that this is going to be the smallest side because it is across from the smallest angle measurement, right? 30 is our smallest angle measurement, and that's going to be across from our smallest side length, which is 5. You find the smallest side, which is 5, and then you use that to calculate your hypotenuse, which is twice that, or 10. And then you come over here and you put this number again, and you plop a root 3 after it. So we have 5, we double it to get the hypotenuse, and we plunk a root 3 at the end to get the other leg. Let's do another example. Let's say that we have this. This is a 30, this is a 60, and there's our 90, okay? And what do we know? Well, we know that this is a 24. We know that our hypotenuse is a 24. We should be able to figure everything else out. So, the short side is half of the hypotenuse. So what's half of 24? 12. Once you figure out the short side, you can figure out the other side, 12 root 3. Because all you have to do is find the short side and plunk a root 3 after it. Again, notice that the short side, which is 12, is across from your smallest angle, which is 30 degrees. Okay, so let's try one more. This will be our 30. This will be our 60, right? And we know that this side right here is a 9. Okay? So what can we figure out? Now this is a little bit more complicated. Remember, it's this, whatever this is, times root 3 equals 9. So x times root 3 has to equal 9. So x is going to equal 9 divided by root 3. Okay? And then we could rationalize this denominator, and we get 9 root 3 over 3. And then we can break that down into 3 root 3. I know, that was a lot of algebra right there, wasn't it? But you could see now that if you take this and you multiply it by root 3, you're going to wind up with 9. This side becomes easier. Once you figure out your short side, you just have to multiply by 2. So that's going to be 6 root 3. All right, so those are your 3 special right triangles. 45, 45, 90, 30, 60, 90, and 3, 4, 5. Get used to looking for those because it'll save you a lot of time and trouble.